Hey guys, in this third example, if you're watching them in order, I'm going to be showing you how do you know when the function is no solution. So we've done two solutions, we've done one solution. How do you know when there's no solution? Okay, so I'm going to do this example here that you see in the screen. 2 times the absolute value of x minus 1 plus 3 equals 2. I will show you by hand, and then I'll show you by the calculator with decimals on how to do it. All right, so remember, by hand, we want to make sure that we isolate this absolute value part first, right? That we leave this by itself before we remove the absolute value symbols. So get rid of the 3, get rid of the 2, and then we can separate this into two parts, the negative side and the positive side. Let's get started. So I'm going to first start by moving the 3 over. I'm going to subtract 3 on both sides. And I have 2 absolute value of x minus 1 equals negative 1. I still want to make sure that I leave this piece on its own, right? So I got to get rid of the 2 that's in front of it. Since it's 2 times x minus 1, I do the opposite by dividing. So divide both sides by 2. And I have the absolute value of x minus 1 equals negative 1/2. Or if you prefer, 0.5. Negative 0.5. Okay? So I'm going to move it to, now I can split it into two parts, the negative side and the positive side. Okay? When I split into two parts, I have x minus 1 equals negative 1/2. Or let's do 0.5 so you can see it easier. Negative 0.5. And then x minus 1 equals positive 0.5. I have my two scenarios, the left side of the graph and the right side of the graph. And then we just solve for x. So we add 1 to both sides, plus 1. So you get x equals 0.5. We do plus 1 on this side, and you get x equals 1.5. So far we have two tentative solutions here, right? We have the 1.5 and the x equals 0.5. So we always want to be able to go back into the graph and check to see if the solutions we got are actually true. When they don't work out, we call those extraneous solutions because they were like errors that happen in the math. We're always going to be able to solve for x and isolate the variable. The question is, are those variables or those solutions true to the equations we started off with? So let's go ahead and graph this. Remember, we want to split this into two parts, the left side of the graph, right? We're dealing with the left side of the graph, and then the right side of the graph is a different function. So we want to know, when does this function equal 2 on the right? So I'm going to change different color for the 2 on the right, and those are my two functions that I'm going to graph, the left and the right. So let's start with f of x equals 2, absolute value, x minus 1 plus 3. When does this function equal to 2? So the second piece is f of x equals 2. Will I ever find an x value that will equal the 2 in this scenario? And the answer is no. Notice how this line down here at 2 does not intersect our graph. There's no solution. So these answers, the 0.5 and the 1.5, would have worked if the graph was flipped upside down. If it was flipped, then it would have crossed that 0.5 and that 1.5. And that's part of why we call this a no solution, because there will never be an x value here for this function that will ever equal to 2. It does not exist. Whenever you see the graph and the other line do not intersecting, we call that a no solution. Now, why does that happen? Why does it happen that we have no solution? Well, everything looks good here, right? Everything is positive, everything we're dealing with is good. But notice that here at the bottom, right before we split it into two parts, this is the most important section of the graph, right? Whenever we have two parts, before we split into two parts, we want to look at the signs. Look at this right here. We have the absolute value of x minus 1 equal negative 1/2. That is a red flag for me already. Why is it a red flag? This pops out at me because we should never get a negative answer. and the absolute value. The purpose of an absolute value, and I'll show you here, right? The absolute value of any number, let's say negative 10, always come down to a positive. We get a positive 10. The absolute value of a positive number, like positive 10, is also positive. That's really the rule of an absolute value. The absolute value turns any number into the positive version of itself. The absolute value of a positive is a positive. The absolute value of a negative is a negative. You will never take the absolute value of a number and get a negative, ever. Absolute value lines are sort of like talking about distance in some location. If we're going to go to Austin and it's 80 miles, it's 80 miles. Driving from Austin to San Antonio is still 80 miles, or from San Antonio to Austin is 80 miles. The distance doesn't make it negative, right? That doesn't change. So absolute value lines are really talking about like distance, displacement. You'll talk about more about this in physics, but absolute value lines are focused on the positive aspect of whatever you're dealing with, always. So you're never going to get some absolute value number here. Sorry, you're never going to get an absolute value and ever get a result that's negative. Whenever you're solving a problem, right before you split it up, if you get a negative, that should tell you this is going to be a no solution scenario. This already is going to tell me that these are not going to work. Now, you'll always have your graph, thankfully, to check your work to see if it actually intersects. If it doesn't intersect, no solution. But I can already tell automatically from here, when I'm solving this, as I start getting to the last step, right before I split into two parts, if this equals a positive, you're going to get an answer. If this absolute value equals a negative, no solution. All right, guys, I hope this helps. And please let me know if you have any questions. And as always, I'll calculate later.